Okay, so what we're going to be doing is we're going to be going through today, we're going to be factorizing monic trinomials. And these are, now, if you think about it, a monic trinomial is something tri, meaning three. Okay, so we've got three terms, and monic, meaning that, well, if you think about a monorail, it's a rail with one rail. So monic basically refers to the fact that this x squared has a coefficient of 1. So we've got 1x squared minus 8x minus 20. If I had a 2 here, then, and I was trying to factorize this, then I can't factorize using this method that I'm going to show you today. So if this is a non-monic trinomial, there's another method which we look at in a later exercise. So we're going to be looking at monic trinomials where we've got the coefficient of x squared is 1. And we'll do some where we have to take out the common factor, and then later on, well, we'll bring it all together, and we'll even do algebraic fractions with those. So we're going to have to feel pretty comfortable with factorizing first. All right, now, just quickly, a little bit of the theory. When factorizing these, again, this is talking about a monic quadratic because the coefficient of x squared is 1. But really what we're doing is we're sort of doing an extension of what we did with grouping, which is when these two terms, we basically want to split this up into two terms. Okay, and if I split it up into two terms, I have 4 terms, and then we can use grouping. And I'll show you that in a second. But what we really need is that if I've got some quadratic in general, I need two things that multiply, two numbers that multiply to give this constant term. Okay, now they've said m and n in this, and I need those same two terms, I need them to add to give this middle term, the coefficient of x. Okay, so let's say if we're doing this one here, where I've got factorizing x squared take 6x minus 72. What we're looking at is two things. Now, sometimes I'll call them A and B. So two things that multiply to give not 72, but minus 72. And those same two numbers, they have to add to give the coefficient of that middle term. So A plus B would have to be equal to, well, the number in front of x is minus 6. Okay, so as you can see that I need those two numbers. Now, look, first of all, I think it's a really good idea if you've got 72. Let's list all the factors of 72. So 1 times 72 is clearly 72. 2 times 36. 3 times 24. 4 times 18. 6, and also they're probably really missing one. 6 12s are 72 and 8 9s are 72. So we've got to look at all of these numbers here and decide, hey, what combination of those can we pick two numbers such that I get them and they multiply together to give minus 72, and they add to give the negative to give this thing here, this negative 6. All right, now I'm just going to. All right, so what we've got is we've got quite a few things to consider, but as we've talked about, that a lot of these numbers aren't, it's not, 1 times 72 is there's no way that we're going to be able to add those to get negative 6. So as we get closer and closer, we want to consider, no, there's no way they're going to work. What we need is 12 and 6, but it's negative 12 times positive 6 is negative 72. And also, we've got those same two numbers have to satisfy this one as well. So negative 12 plus 6 is negative 6. Now, if it satisfies them both, now this is what's actually happening in the background. There's a bit of a shortcut I want you to notice. I want you to notice these numbers here. These numbers here are a big, we can use them as a shortcut, and we've virtually factorized them by finding these two numbers. But let me show you how. The long way, basically. What we do is now what we've got is these numbers here, these minus 12 and positive 6. What we're doing is we're splitting this thing up, this middle term, into two terms. Okay, x squared, and you can see here that's going to be minus 12x plus 6x. So you can see there that there is combination. Minus 6x is a combination of minus 12 plus 6x. and then I've got, of course, minus 72 on the end. Now, I've got 4 terms, so when you're thinking 4 terms, what should you be thinking? You should be thinking of something starting with G, which anybody can shout it out. It's what? What are we looking for? We're looking
Grouping.
Grouping. Okay, so we're looking for grouping. When I've got 4 terms, I'm thinking grouping. Very good. So you can see here that let's group these two together and let's factorize them. Let's take the highest common factor of this out the front, and likewise of this, highest common factor. So if I take out the highest common factor, we've got x times x minus 12. And over here, look, this should be a big hint. X minus 12, I'm just going to write it out again, because if I take that out the front, well, we can put a 6 out the front. Okay, and of course a positive 6. Now, if you can see that, just like what we've been doing in previous exercises, if I've got this thing over here where they both have an x minus 12 in common, then that is actually a common factor between the two. And if I do that, then let's do that. X minus 12, factorizing that. And of course, if I multiply that by an x, and then obviously plus 6, we have actually now factorized that. Now, as you can see, I've done it the long way. You don't have to do it this way, but that's how we actually do these things. You can see here, look, x, if you throw an x with a minus 12, and you throw an x with a plus 6, those two magical numbers, we have now factorized this expression. Okay, now you might be asking, why are we doing this? Well, if I can just show you just quickly, let's sketch this quadratic here, this quadratic x squared minus 6. Well, if I go ahead, and I'll do that in a second, but what we'll do is, let's say if we've got this thing which is a quadratic, and we've got y is equal to x squared minus 6x minus 72. And let's say that the x-intercepts, we let y equal 0, okay, to find those. So if I do that, then I've got this. Now, that's not very useful at the moment. But if I factorize this, which we've done, okay, if I've done that, this is x plus 6 and x minus 12, what you'll notice is that, hey, there's only 2 ways in which this statement can be true. And by the way, if you're listening, for anyone out there, what would x have to be in here? What would x have to be in here for this to be true, for this to be 0? X would have to equal what? And what would x?
Negative 12.
Yeah, so x would have to, well, actually, if you think about it, 12 take away 12 is 0, isn't it? How does this equal 0? How does this equal 0, and how does this equal 0? So it's actually the opposite. It's sort of like 12 take away 12 is 0. So therefore, x equals 12 is going to be one of those solutions. And the other one over here, it's going to be minus 6 plus 6 is 0. So think about it. The only way if I've got two things and they're multiplied and the answer is 0, there's either this thing equals 0 or this is equal to 0. And this is what we call the null factor law. And we're going to basically look at that much, much later. But this thing is really important, that if I factorize, then it actually, so, okay, what's inside that bracket? How does that equal 0? Well, x would have to equal minus 6. And there's 2 brackets, so of course we're also looking at x equals 12. Now these, I want you to keep these in your mind right now. Okay, x equals minus 6 and x equals 12. I want you to keep those in your mind. What we've just literally just done a bunch of things, and we've let y equal 0 to find the x-intercepts. Let's see if I go ahead now and I go to this screen. So I'm going to go and open up a calculator screen. So just give me a second. I'm going to open up a calculator screen, and I'm going to get you to, if you've got a calculator now, can I get you to please get your calculator out? And I want you to do exactly what I'm doing now. And I want to show you this. If you can sort of see where we're going, you're probably more likely to go, okay, well, there is a point to factorizing, and there absolutely is a point to factorizing. Okay, so now just quickly, I'm going to share my screen with everyone in this here so you can see it. All right. Okay, so we're here, and if I want to add a graph, I just simply go to the home screen, and we can just go add a graph down here. And we want to sketch the graph of what we had, x squared. Take away, now, of course, that middle term that we had to bust up into two things, it was negative 6x. And then we had negative 72. Press enter. Now, by the way, this thing has, we've got to zoom out. Okay, so we've got this what's part of a quadratic, and if I go to Windows and I go Windows Zoom and I zoom out and I sort of center around here and I do it once, twice, a few times, actually this is the shape of a quadratic. It basically looks like this. Goes down here and it goes sort of turns and it comes back up here. And notice that it's got two X intercepts. And if I go to Analyze Graph, and I go to 0, and I want to pick a point to the left and I pick a point to the right, look at that, we've got -6. And if I was to do that again, Windows Analyze Graph, and 0, we have got that there. So this is why we're doing this. We've used our calculator to find the x-intercepts of -6 and 12. And if I was to have a look at what we've just done, then there they are. We've just shown you right here. Okay, we've just there they are. There's x equals -6, x equals 12. We have to factorize to find those intercepts. All right, so let me go through a couple more of these, and then I'm going to get you, if you're watching, to have a go at these as well. So the first one, let's me talk through the process again, and I'm going to do it the long way to show you, but also to show you that there's a shortcut as well. So first of all, I need two things that multiply to give 15 and add to give 8. And look, if you want to, at first, if you want to list the factors out, 3 5s are 15. 3 5s are 15 and 1 times 15. These are the only factors. Now, there is no way that 1 and 15, any combination of those can multiply and then be added to give 8. So they're out. So we know it's 3 and 5, and it just so happens to be that it's just both of them are positive. So 3 times 5, this is quite nice. 3 plus 5 is 8. So therefore, if it satisfies both, now look, there is a shortcut, but I want to show you, of course, what is actually going on in the background. We're splitting those up into two terms. That 8x is now 3x and 5x. Okay, so that's going to be, there you go. We have got split that up. And in grouping, we're going to take out the highest common factor. So x plus 3, this should be a big hint. We want to see that again, and if I take out a 5, there you go. We have now factorized that. They have an x plus 3 in common, and if I multiply that by x and plus 5, we are done. And as you can see, yes, there is a bit of a shortcut, because if I have an x and I put this number in, x plus 3 and x plus 5, we've actually now factorized that. Now, another type is over here, we see that this is a non-monic trinomial. This is a non-monic. We can, however, if we can take out a common factor and make that, so if I take out a 2 and I leave that with x squared and -5x and -14, we can factorize this just the same way. But just remember that the 2 doesn't go anywhere. We've got the 2 sort of comes back at the end. So if I was factorizing this, I need two things that multiply to give, well, they multiply to give -14, the last term. Okay, and then they add to give -5. Okay, so again, we think about the factors of 14, 1 and 14, 2 and 7, they're the only two options. So clearly there's no way you're going to get 1 and 14 to add to -5. So we know it's going to be the 2 and 7, and we know that one of them is going to be negative. Well, considering that those two things are going to add to give a -5, Therefore, that's going to be negative 7 plus 2 is negative 5, and negative 7 times 2 is negative 14. And look, we can do this way forever, okay? But you hopefully can see that there's a big shortcut to that, and that is that, okay, if I wanted to factorize those, if I find those numbers, then we've got x minus 7 and x plus 2. Okay, let's have a look. Okay, so let's have a look over here. We've found that our two numbers that basically split up, we're splitting that up. The long way is that's minus 7x plus 2x. But if we can find those two numbers, then we have basically factorized, haven't we? Minus 7 and positive 2. Okay, so, all right, there's a couple. So Lucas, what do we need to do to solve this? We need to find two things that multiply to give 6 and add to give minus 5. What are they? Did you come up with them?
I couldn't really find this one, but I knew that they had to be a positive because it's a negative 5 at the end, so one number must be a negative. Is that right?
Yeah, that's right. So one number has to be a negative. Let's think about the factors of 6. There's only a few factors: 1 and 6 and 2 and 3. That's it. Now we know that 2 and 3. Well, there really could be two ways, but since that this is a negative 5x, we know that if I was to do negative 6 times positive 1, then that's not going to work out. So I guess if we go here, negative 2 times negative 3, a negative times a negative is a positive, and a negative 2 plus negative 3 is negative 5. Now, if we find those things out, that's basically the magic to factorizing. If we can find negative 2 and negative 3, then really, again, we can do it the long way, of course. What we're doing is, and I think it's important to know what we're doing, but really what we're doing is breaking that middle term up into two terms, 1, 2, and then we're using grouping. So then we've basically, let's break that up, x minus 2, if I factorize that, and that should be a big hint, x minus 2, we want to see that again, and that's going to be a minus 3 over there. So that's how we can then basically factorize this to be x minus 2 and x minus 3. Okay, and just quickly, I might just ask anyone what did we get for over here? Did anyone get this? Did anyone get this? Who is out there? What?
Negative 4 and negative 4.
Yeah, negative 4 and negative 4. So we can see that if I've got here, it can be the same number. Okay, so think about the factors of 16, 1 and 16, 2 and 8, 4 and 4. There's no way that 2 and 8 any combination can add. So in this case, it's going to be negative 4 times negative 4 and negative 4 plus negative 4. They're both satisfied. And let's do this as a shortcut. It's x minus 4 times x minus 4, which, by the way, can be x minus 4 squared. Now, this is actually, if I was to show you here, how would this equal 0? Let's think about it. If I wanted to find the x-intercepts, what would I do? I'd let y equal 0. So anyone, I'm sure if you're watching this, you can think about it. What would satisfy this equation? What would x have to be for this to be true? What would x have to be? So if I was trying to find the y-intercept, I'd let the x-intercept, let y equal 0, then x would have to equal 4. Okay, so let me show you the calculator screen. Let's go over to the calculator screen and let's have a look and let's sketch. Let's sketch that thing that we just did. And if we can do that, so I'm going to get rid of this. I want to go home. No, we want to do a new one. And we're going to do x squared, take away 8x, and it was positive 16. And as you can see, there it is. And look, we can even count. We wouldn't even have to use the calculator. 1, 2, 3, 4. You can see there that x equals 4 is our, it also happens to be the place where it turns, which we'll get into later. But as you can see, x equals 4 is that x-intercept there. So now I'd like you to have a go at these ones. If you're watching this later, pause it, try these. I really want you to try these now because I'm going to go through these in a sec. All right, Oscar, so what have you got here? What were your two numbers here? We've got two numbers that multiply to give 12 and add to give 7. What did you have?
4 and 3.
Yep, so 4 times 3 is 12 and 4 plus 3 is 7, which again, if I can show you, I think it's really important to know why we're doing things, but really that's what we're doing. We're breaking up two terms, one term into two, 7x into that, and then we're using grouping in that. But of course, there is a bit of a shortcut to that because we don't need to do all of that grouping. The hint is that that x plus 4 times x plus 3, those two numbers with an x and the sign, we've now factorized. Okay, so there you go. We've now factorized that. All right, Oscar, what did you get for B?
-6 and -4.
So Oscar has said that we've got -6 and -4. Well, they both multiply to give 24. Yes, and they add to give -10. So we won't do it we could do it the long way, and we're going to get that every time, but let's just do that straight away. We've got x minus 6, x minus 4. It's now factorized. So if all of a sudden later on, when I ask you to sketch a quadratic, we could turn that quadratic, which is this thing here, we could turn it into this, and we can find the x-intercepts. That's the whole point of doing this. We can find the x-intercepts. Okay, and lastly, Oscar, I'll get you just to do this one with me. What did you get for this? We need two numbers that multiply to give 9 and add to give -6.
-3 and -3.
So -3 and -3, and -3 and -3 add to -6. So again, we can just use that as x minus 3 times x minus 3, or we could say that y is equal to x minus 3 squared if you like, or if that was so. We've just factorized that. Now, just quickly, I'm going to go through these ones. With these ones, this is what we call a non-monic trinomial, which, by the way, is going to be our next exercise, which we look at. But we can turn this into a monic trinomial, i.e. this number out the front is 1, and we can do that by taking out the 2. Okay, and if we take out that, it's not going to be too hard on ourselves. We can now factorize what's in here. I need two things that multiply to give -6 and add to give -1, and those two things are, well, we can look at the factors of 6. 1 times 6, 2 times 3. There's no way we can do a combination of those to get me -1. But if I do 2 and 3, -3 and +2, that's going to work, and so's that. So there you go. Once we've done that, now when we factorize, remember we've just factorized what's in here, so the 2 didn't go anywhere. So if we've got the 2, we put it out the front with x minus 3, x plus 2. We have now done this. Now, in the next thing, if you would like to right now, have a go and look, if you really want to challenge yourself, I want you to try this one right here. As you can see, this is a really long one. We're going to go through this in a second, but I would like you to pause this if you're watching, and I'd like you to try this one now to finish off, and we're going to go through that in a second. All right, so I've broken this down, and as you can see, this is all my working that I've done so far. Over here, we've got for the x squared minus 9, I can do this two ways. We first of all looked at, if I see two terms, I can use the difference of perfect squares, okay? So the difference of two things squared, difference of perfect squares. So if I set this up as x squared minus 3 all squared, then using my difference of perfect squares rule, where a is x and b is 3, then that simplifies to x minus 3, x plus 3. We've been doing that in previous exercises, but for those students who have struggled, why don't we make this a trinomial? And maybe we'll eventually realise that, hey, if this middle term is 0x, then I need two things that multiply to give minus 9 and add to give 0, and they are 3 and minus 3. And as you can see, that's another way of factorising those. This one over here, we've got two numbers that multiply to minus 15 and add to minus 2, and there we go. We've got those two numbers of minus 5 and 3. And over here, minus 5 and 1. As you can see, we've done that. And finally, this one here, we've just got to take out the highest common factor. This is just a linear, taking out 2 out the front. Now, if I can just finish this off, if we can just bring all of this together, then hopefully we're going to make life easier for ourselves. So over here, x squared minus 9 factorizes to this. And then we have got x minus 5 and x plus 3 over here for factorizing this. And then over here, we've got x minus 5, x plus 1. And over here, we've got 2x minus 3. So hopefully you can see that, look, these are all multiplied, so that these cancel. These cancel over here. These cancel over here. And I'm just simply left with x plus 1 over 2. So if you can do this one, you can do, well, you've really started to master factorising already. I won't expect you to be able to just do that, but hey, if you can do that, and if you practice those, then you should. Okay, so look, I hope that makes sense. I'm Mr. Underwood, and I hope that it did make sense. I recorded this live in class. So if this does help you factorise trinomials, then fantastic. All the best.